The Q-Sys ecosystem includes an event logging feature that can be used to keep track of what's happening on your core, including when the status of inventory items change, when clients log into QRC, and when paging events occur. Q-Sys Designer even gives us a way to add our own messages into the event log so we can keep track of our own custom events as well. Unfortunately, the event log is crippled by the fact that it only holds 5,000 messages, and there's no native way to send the messages from it to external systems. Today, I want to show you how to manipulate the event log to do our bidding by adding messages to it and sending messages from it to external systems. Along the way, I'll talk about some of the limitations of doing so that we just have to contend with. The first thing I want to do is bring in the event logger and event log components. The event logger simply allows us to add messages to the log with a specified severity and additional arguments if desired. The event log has two pins: last entry, which gives us a text representation of the latest log event, and Lua table, which gives us a string representation of a piece of Lua code that we can run to get a table. Yeah, it's odd to explain, but I'll be demonstrating it in a moment. I'm going to expose the Lua table pin on the event log, create a control script with one input pin, and wire it to that Lua table pin. Opening up the script, I'll create an event handler, print the string value of the handled control, and hook that to our input. I'll emulate the design and fill in some information in the logger. Once I press the Publish button, you can see the result of our print statement in the output window. If I copy the text into the script and format it nicely, it becomes more clear what we're dealing with. This is exactly the type of thing we would enter into a script to generate a Lua table, and all we need to do to execute this in real time is pass it through the Lua load function with an extra set of parentheses at the end. In order to see the results, we'll also loop through and print all of the data in the table, with a little extra formatting for clarity. Now, if I trigger a message via the event logger, we see a few items show up. The message is the text we put in the event logger. The date is the date and time of the event, but it is important to note that this is in UTC, so it would need to be converted if we wanted to see it in our local time zone. For our work today, we'll be leaving it as is. The severity will be either normal, warning, or error. The file name is meaningless to me so far. I've only ever seen it blank. The category is the group that the message belongs to. And lastly, the source is what device or component generated the message. In this case, it's empty, which makes this a great time to talk about some of the limitations and quirks of the event log component. There are three major issues I've noticed here. First, not all events from the core's event log show up in the event log component. Most notably, access control events from the configurator web interface won't be logged here, but QRC connections will appear whether or not you have it set to require a login. Second, you won't get the design start or design stop messages that appear in the core's event log, so it may be a little difficult to determine when the design file changed or the core rebooted. This can be sidestepped by sending out your own startup message via the script that's communicating with your external system, but of course it's not perfect. Lastly, I mentioned that the source was empty during our last message. From what I can tell, this generally means that the source is the core itself, so you may want to substitute that before you send the message out. With that being said, I'm going to quickly implement changes from the last two items, and we can work on sending this data out. The external system I'll be sending the messages to today is Vector. I won't be going through how to set it up, but I do have it configured to receive HTTP events and print them to the console in JSON format. In order to send our events to it, I'm going to set up a few things. In addition to the information we already collected, I also want to send the name of the core And in order to do that, we need to look through the design's inventory and find the device with a type of core or processor. Core will show up on designs running 9.3 or earlier, and processor will show up on newer firmwares. Once we find that, just get the name and return it. We'll also set a fallback name just in case. We will add that to our table under a key of host. Since we'll be using the HTTP client to send our data, I'll also create a quick response event handler that just tells us what we got back, and I'll add the rapid JSON library so we can encode our data. Now we can assemble our HTTP request with all the necessary information, and we're done. If I split my windows here, dragging the vector console on screen, and save the script, we see the startup message immediately appears in the vector window. Now that we have our log messages going out, let's talk about how to get them into the event log. There are 3 ways to do that, but I'll only talk in depth about 2 of them today. The first one I already showed, the event logger. If I open it up, you can see 4 controls. The log entry, which is what will populate the message field of the log. The severity, which is a drop-down that allows you to select error, warning, or normal, an argument field, and a publish button. The component actually allows for 0 to 16 arguments to be added, but it defaults to 1. Arguments can be added to the log entry by placing curly braces where you want each to go in order. The publish button is a trigger button and is what actually causes the entry to be added to the log. Nothing will happen until this is triggered. To demonstrate, I'll just click the publish button now, and you can see my entry appear in the vector console. Easy. The second method to add entries is directly via a script. Unfortunately, this is even more limited than the event logger, only allowing for a normal or error severity, and the log entry isn't automatically added to the debug output, so you will need a print statement if you want your information there too. To quickly demonstrate, I'll open a script here, add a call to log.message, and type in my message. Once I save this, the message appears with a normal severity. If I change this to log.error and save, we see the same message, but with the severity set to error. Now, I did say that there are 3 methods to get information into the log, and I do want to quickly mention the third. If we click the plus icon in the inventory panel and go to Control, there's this monitoring proxy. What that allows you to do is effectively add the status control of any plugin or script to your inventory so it can be logged in the event log and sent to Reflect. It also allows you to create log messages like the event logger. I really hope that QSC will improve the functionality of the event log to allow integrators to send the messages out more easily, maybe by adding a syslog sender. But I'm not holding my breath. Fortunately, it isn't too difficult to get this information out, and if you have a system you can send it to, it can definitely help investigate issues in your deployments over time. I hope you learned something. Thanks for watching.